Good morning, friends. So today's we are delivering the lecture on neighborhood and open set and the closed set. So it is a part of real analysis, and we will be discussing what do you mean by neighborhood of a point. Now, as the name suggesting that when you are talking about the neighborhood of a point, it means the point has to be very close. That is, the topic is neighborhood of a point. Neighborhood of a point. In short, we call this as NBD also. In short, we call this as NBD. Now, uh, let us consider any subset of a real line. Let S be any subset of R. We are considering any subset of R. Now, we can say that S is said to be a neighborhood of a point P. Now, see, what exactly is the meaning of that? If I consider this is my real line, and I am considering S is a subset of the real line. If I am considering S is a subset of a real line, and there is a point on the number line that suppose it is P, and this P belongs to S. Please try to understand that we have to construct this P is a member of S. Now, if we construct an interval that is P minus epsilon, open interval, and P plus epsilon, where epsilon is very small, greater than 0, and it is very small. Just try to understand that if this condition holds, that is, if there exists an interval P minus epsilon and P plus epsilon, and you can say that P must belongs to it, and it contained in, you can say that it contained in S, it contained in S, then we say that then S is a neighborhood of P, of a point P. Now, friends, up to this point, I have just explained you that what exactly is the definition. It means if you consider any subset of a real line. So this is our real line, any subset S. It has to be a subset of real line. So now you have to consider any point P belongs to S and then construct an open interval that is P minus epsilon, P plus epsilon that must belongs to and it must contain in S. If this condition holds, then we say that. Now let us consider a few example of it. Now, my first example is, can we say that set n of natural numbers? Set n is set of natural numbers. I will say that it is not a neighborhood of any of its points. N is not a neighborhood of any of its points. Why, friends? Now let us understand it. Since n is a natural number, suppose, if possible, suppose, let I will say that some a belongs to the natural number. Now see, if I construct an interval a minus epsilon, a plus epsilon, now see that a belongs to it. I will say that it is never contained in n because this interval contain rational as well as irrational numbers, and which is not a part of the natural number. It will always contain rational as well as irrational numbers. As well as irrational numbers. So we can say that set n of natural number is not a neighborhood of any of its points. Now this is the first example where it is not the neighborhood of any of its points. Now suppose if I consider any finite set, suppose I have given you any finite set. Suppose my any finite set A is, suppose I'm considering 1, 2, 3. I will say that it is not a neighborhood of any of its points. Again, I will say that A is not a neighborhood of any of its points. What is the reasoning behind it? Now see, suppose if I say that if possible suppose A is a neighborhood of 1. So now, if it is there, I am constructing an interval that is 1, 1 minus epsilon and 1 plus epsilon. You take epsilon as say 1 by 100 if possible. I will say that 1 certainly belongs to it, but I will say that it is never contained in the set 1, 2, 3 because it contains infinitely many numbers. It is an infinite set, so which is not possible. Now the next question arises, friends, then what type of set we can say that it is a neighborhood of each of its points? Now it is a very important question to know that what type of set we should consider. Now, can I say that any open interval is a neighborhood of each of its points? Of course, yes. It is a neighborhood of each of its points. The reason is very simple. Let a comma b be any interval, be any open interval. Now see, if I say that if there is a point x belongs to this open interval, then certainly you can say that minus epsilon, it is there, and I will say that it is contained. So you can say that an open interval is a neighborhood of each of its points. Is a neighborhood of each of its points. Now the next question arises, what you can say about any closed interval? Now try to understand that. A closed interval is a neighborhood of each of its points except endpoints. Now certainly you can see that if I write this closed interval, I know that the open interval a comma b is always contained in it. Now I will say that a uh, this bracket a comma b is not a neighborhood of a and b. Reason. The reasoning is very simple because if you consider an open interval around this point a, that is a minus epsilon and then a plus epsilon, then certainly this particular part, you can say that if I am considering this particular region, this region is not a part of this. Now you can say that certainly a belongs to a minus epsilon A plus epsilon, but it is not contained in this interval. Similarly, when you are constructing the neighborhood of B, if this is a point B, then B minus epsilon and B plus epsilon. You can say that certainly this B minus epsilon, B plus epsilon, you can say that B belongs to it, but it is not contained in this open interval. So you can say that it is the neighborhood of each of its points, but except the end points. It means you can say that it is not the neighborhood of A and B. So now I am concluding. You can say that I am giving you some example. The set n of natural numbers, whole numbers, integers, and even if I will say that the rational numbers are not a neighborhood of any of its points. Any of its points. That you can verify it. And I can say that the set R of real number is a neighborhood of each of its points. So I have given you the enough examples of on neighborhood. So I hope this concept must be clear to you, friends. So please see this video carefully, and I hope you must like this video. And in future, I will keep posting the videos of small concepts so that you can revise your concept.